everyone, it's me, Kekler Ayanding, and together with my groupmates, Sheila May Lantaka, Ira Gilianes, and Chesa May D. Tagbo, we will be presenting to you our soap, which is the Sana Oil Handmade Soap. So, without further ado, let's get started.
So here are the materials and equipments that we use during our soap making. In the list, we have steamer, packet scale, face mask, stirring rod, medicine dropper, cloth, plastic spoon, paper bags, stick blender, graduated cylinder, paper towel, soap molder, spatula, dishwashing liquid, baker, gloves, and the pitcher. We have here the steamer, used to disinfect and sanitize. Packet scale is a device for weighing NaOH. Stirring rod, used to stir or mix solutions. And cloth, one of the important materials in soap making, it is because it covers a soap molder for curing process. And gloves, all soap makers should wear gloves to protect against skin absorption of chemicals like the NaOH. Graduated cylinder, used to measure the volume of a liquids. Baker, used to hold the mixture that will become the soap. The soap ingredients. First, the palm oil, 200 grams, coconut oil, 100 grams, sunflower oil, 100 grams, water, 152 grams, NaOH, 62 grams. Additives and their benefits. Watermelon scent is a great ingredient to use in soap making, as it helps to create a rich and creamy lather while also providing skin nourishing benefits. Blooming floral scent helps to moisturizing the skin and has wonderfully soft whip texture. Our soap is unique from the other group because it has a sunflower oil, which is perfect addition to handmade soap, and it's packed with essential fatty acids and a vitamin E. So it feels moisturizing on the skin. It's perfect for dry areas because it's lightweight, but it doesn't absorb too quickly. Also, the vitamin E present in sunflower oil has antioxidants that help with premature aging, wrinkles, keeping your skin looking young and fresh.
So there are 14 procedures in making your own organic soap. First, as what you can see in the picture, we prepare all the ingredients and laboratory glassware and equipment. We use gloves, face masks, long sleeves, and closed shoes when doing this lab activity. Second is we sterilize our pre-washed towel or cloth for soap insulation process through steaming. Then, third is we clean the soap molders, containers, and glassware with dishwashing liquid or paste. 4. Weigh and combine the palm oil, which is 200 grams, coconut oil, 100 grams, sunflower oil, 100 grams, and set aside in a larger and clean plastic container or pitcher. Procedure number 5. Measure 152 milliliters of distilled water using a graduated cylinder or beaker. Procedure number 6 is weigh 62.766 grams of NaOH using a pocket weighing scale. So, procedure number 7. Slowly add NaOH to the distilled water while gently stirring until the NaOH is fully dissolved and the liquid is clear. Let it cool down for a few minutes. Procedure number 8. Slowly and gently pour your lye water into your oil mixture. Procedure number 9. Pulse the stick blender a few times and watch as the oils and lye start to combine. Switch between short pulses and stirring with the blender until the mixture comes together to a light race or liquid thickness. And procedure number 10, working quickly, stir or Do not blend in the essential oils or fragrance oils. 1 drop of phenoxyethanol and other additives. So, procedure number 11. Once your soap reaches about a medium trace or liquid thickness, pour it into your mold. Scrape the container using a plastic spatula to ensure no soap is left behind. Tap the molds on your table or counter to release any trapped air bubbles. Procedure number 12. Insulate the molder by covering it with a sterilized cloth to allow the soap to sit in the molder for 48 to 72 hours, 2 to 3 days at room temperature. Procedure number 13. Unmold the soap or cut into bars if you're not using a soap molder. Weigh a sample or initial weight. Allow to cure for 7 to 10 days, then weigh a sample again to see if there are any changes in terms of weight. After the curing process. Last is pack the soap with your desired soap packaging. Soap will be ready to be used after the curing process.
Findings and conclusion. Based on the experiment, our goal in making organic soap was successfully achieved to synthesize a sample of handmade organic soap and to test soap produced. From this experiment, the produce of making soap involves the basic ingredients, which includes the palm oil, coconut oil, sunflower oil, water, and lye or NaOH. The formation of making a soap is called as saponification. When the 62 grams of lye or the NaOH were added with 152 milliliters of distilled water, its temperature rises due to the stirring method we conduct. The mixture of lye and the oils are not totally mixed thoroughly, rather, it sinks to the bottom. But with the help of the stick blender, the oils and lye start to combine. Switch between short pulses and stirring with the blender until the mixture comes together to a light trace or liquid thickness. While doing this procedure, we observe that its color is changing due to the mixing of oils and the NaOH. After that, we observe that the result of the mixture remain constant. Through our journey in making organic soap, the key thing we learned is to follow the step-by-step procedures to achieve a better result and produce a high-quality product.
Fatty acids are important in soap making since they are building the blocks of soap. Each fatty acid offers distinct qualities to the finished soap product. Here is a quick explanation of the importance of fatty acids we mentioned in our soap recipe. So first is lauric acid. It adds firmness and creates a thick, fluffy lather with cleaning capabilities. It is typically found in oils such as coconut oil. Linoleic acid. It is an essential fatty acid that adds to the conditioning characteristics of soap. It keeps the skin moisturized and its barrier functions intact. Linoleic acid. Linoleic acid is an important fatty acid that improves the conditioning characteristics of soap. It hydrates and soothes the skin. Linoleic acid is abundant in oils such as flaxseed and hemp seed. Myristic acid. It helps to harden and stabilize soap while creating a rich, creamy lather. It's ubiquitous in oils like palm and coconut oil. Oleic acid. It gives soap conditioning characteristics, allowing it to be hydrating and soft on the skin. Oleic acid is abundant in oils such as olive oil and avocado oil. Palmitic acid. It helps to increase the hardness and stability of soap, resulting in longer lasting bar. It can be found in oils such as palm oil and tallow. Resinolic acid. Castor oil contains a unique fatty acid. It improves lather development by adding moisturizing and enrollment characteristic to soap. Esteric acid. Steric acid, like palmitic acid, contributes to soap hardness and durability. It's typically found in oils like cocoa butter and shea butter. Reflection. Making soap was a long and arduous process. What we have learned in our laboratory activity, which is to make a soap, is that it would greatly help a lot in developing the skills and knowledge for students, especially those who love to do experiments. Throughout our journey, we can say that it was indeed a great experience for all of us. In addition, biochemistry is essential for understanding the chemical reactions involved in soap production, whereas agriculture gives information on raw material procurement. With this, we learned about the different features and characteristics of oils and how it is important in making a soap. Also, how it affects its quality. As a result of merging the two fields, we can obtain a better grasp of the science underpinning soap manufacture and its relationship to agribusiness.